In this exercise, we'll model a brake pressure tank, a small tank that releases all pressure by opening to the atmosphere. This time, the layout is already drawn and the data is pre-entered according to the exercise. There are two pipes, one upstream, bringing water into the brake pressure tank, and one downstream. To model the brake pressure tank, we'll use a pressure-reducing valve, PRV. Click the valve icon and place it in the direction of flow. These valves have a high-pressure side and a low-pressure side, so make sure not to install it backwards. Click the valve, set its diameter to match the pipe, and under Type, select PRV. Set the pressure setting to 0, meaning it will reduce the pressure to 0. Now, run the simulation and display the pressures to check the results. Water enters the valve with a pressure of 23.33 meters and exits with 0 meters. The pressure at the tank is also 0, since it's a free-flowing pipe, and this tank, being open to the atmosphere, also breaks the pressure. So why do we model free-flowing pipes with nodes and brake pressure tanks with valves? We are trying to avoid adding tank objects. The reason is that these can introduce errors if their size parameters aren't carefully set, especially in steady-state models that don't simulate changes over time. They may supply water when they shouldn't, or feed the wrong pipes in the wrong direction. To verify this, we can replicate the system using a node with an emitter. The results remain the same. In the manual, you read about model equivalence. This is one example of how a system can be modeled in different ways, some with practical advantages over others. Don't get caught up in unnecessary details or excessive realism. Use your imagination.